Hello and welcome to SudoKanard. Today I've had this very nice surprise by my young friend and Padawan Gelb1, also known as this strange nickname that is Gelb1n or something. And he's made a Scrabble Sudoku. Well, what you may not know is that Erwan and myself have met at French Scrabble tournaments. Actually, that's how we've known each other. And now he's been doing this very nice crossover of Scrabble and Sudoku, and I'm very excited to tackle this puzzle. He's actually very well mimicked the way premium cells are set on a Scrabble board, except that the Scrabble board is 15 by 15, whereas a Sudoku board or Sudoku grid is 9 by 9. But the position of those cells is very of premium squares, I think we are supposed to say. It's very much like on a Scrabble board. So what's the rule? Well, it's more or less a killer Sudoku with cages here, meaning that inside a cage, no digit can repeat, which in most cases wouldn't happen with the very rules of Sudoku, but in this case, this digit could be the same as this one. Now, regular Sudoku rules apply, and premium squares are multipliers for either the whole sum or only the digits. So the color code is like in Scrabble, that's a triple word in Scrabble, so that's a triple sum for the cage. So the real sum here is actually 5. Pink squares are double words, meaning here they are a double sum. All this cage should actually add up to 21, but those cells contain digits that have themselves a multiplier. And so gray, these digits contain a triple digit, so when you consider the sum in this cage, this counts as a triple. You multiply the digit here by 3 for the sum. Well, and those light blue squares are doubled. So this 13 is actually 3 times this number plus 2 times this number. And this cage is 2 times this number plus this number plus this number, and this sum multiplied by 3. And I take it that all those colored cells are actually colored just for the sake of having a beautiful Scrabble board. So that's a very long explanation. Now let's get cracking. So this is actually a 5 cage. This is actually a 12 cage. This is a 20 cage with a double digit. This 19 cage has a triple digit. So this can only be 1, 4, or 7. And accordingly, this digit will be 6, 5, or 4. I love it. That's very unusual. That's a very unusual pairing. That's very nice. That's a very original take on Kira Sudoku. This is actually a 20 cell, a regular 20 cell, which just don't know which digits, and this implies limitations on what can go into here. This 28 cage is actually a 14 cage, but with some triple digit. Well, this is actually a 13 cage with some double digit. this is very weird. A triple digit and a double digit. Oh. Those digits can't be very big. If you take 1 plus 2 times 2 plus 3 times 3, you already get 14. So the triple digit must be very low. Just imagine that this is 3. Then those should add up to 4, which is impossible. So that can't be, it has to be 1 or 2. And if this is 2, then it makes actually 6. And those must add up to 7, making, and this is double, so this has to be an odd digit. Let's say 2, 1, and 3 would fit. 2, no, that's 6. 2, 3 would require 2. 2, 5, 1 would fit. So let's say 2, 1, and 3. Is that correct? That's 6. No, that's 6, 8. 6, 8, so that would be a 5. Let's say 2, 3, so that's 6 plus 6, and that would be a 1. And those are the only possibilities with 2. But with 1, that's 3, and this should be 10. So this should be an even digit. So 10 would be, let's say, 4 plus 6, 6 plus 4, or 8 plus 2. So those are all 5 possibilities for this cage, which is already a lot, actually. This 48 is very restricted because this is the actual sum. And what is the maximum you can have? 9 times 3 would be 27. 8 times 2 would be 16. That's 43. And this would be 5. So this is at least 5. But what else could we have? Is there any solution with an 8 in here? 8 in here would make this 24. 9 here would be 18. And 6 would work. So that would be 8, 5, 9. This would be 9, 8, and 6. Could we have smaller digits? I guess, 9, 7 would make this a 7. 27 plus 14, yes, it would make this a 7. It wouldn't work. And 9, 6 would make this a 9. It wouldn't work either. So with a 9 in this cell, only this works. With an 8 in here, could this be 8, 7? That would be 24. 38. No, we would need a 10. What about a 777? That will make 21. With a double 9, that would be 18, making this 39, and we would need a repeated 9, so it wouldn't work. Only 2 possibilities for this cage, actually. So, left-hand scenario, 8, 5, and 9. Right hand, 9, 6, and 8. Where should I look? That's 3 times 12. Lots of possibilities. This 15 is actually 2 times 3. So it's just a regular 3 times 5. I'm so bad at instant translation of numbers. So it's a regular five cage with 2 and 3 or 1 and 4. This one is wicked. 4 digits, it's a double sum, so the sum is 21, but that's this one is multiplied by 3 and this one by 2. Oh, how do you handle this? 9 is too much. 21, so even 5 is too much. Is 5 too much, really? 5 would make this 15. We need 21. 1 here would make this 2. And we would need, that's 17. For 21, we would need 1 and 3. It wouldn't work. And even with the 2 here, no, with the 2 here, that would be 4. And we would need 2 with those 2 cells. It wouldn't work either. So 5 is too much. So 4 could work, making this 12. We now need 9 more. It could be 1 with 2 and making this a 2 with 2 and 5. So 2, 5, 4, 1 or 5, 2, 4, 1. That's something that's conceivable. What else? What if we put a 2? Then this is 4. We already have 16. We need another 5 without using 4 or 2. It's not possible. Could this be a 3? That's 6. We need another 3. So 1 and 2 would work. So 1 and 2 this way. That would work. But with more in this cell, that wouldn't work. And I'm afraid that smaller digits here produce lots of solutions. Let's recall that this contains either 2 and 3 or 1 and 4. So if we draw the line here, we see that none of those work. All of those assumptions would use both 1 and 2. So this wouldn't have any possible solution. So 4 is not possible here. This is less than 3. This is at most 3. The plot thickens. So now, could it be a 3? So that's at most 3. Okay. Let's write it down. So if this is a 3, then this actually counts as 9, and we need another 12. So let's say this is a 3, another 12. Let's try a 1 in here. That's 2, and we need another 10. And we can't use 1 and 3, and we can't use the 2, because that's 2 and 3 in this case. And we need another 10, so 4, 6 is a possibility. So 1 here, 4, 6, possibly in the other order. So this works. Let's try with the 2 here. That's 4, and that's 2 and 3. That's 1 and 4 actually. So now that's 13. We need another 8 without using 3, 2, or 1. That's not possible. Next is with 4 here, making this 8. We need another 4, which would be with 1 and 3, and that's not possible. So with 3, there are only those two possibilities with 3, 1, 2 and 3, and a 4, 6 pair in those cells. What would work with a 2? That's very... that looks very much like brute force, but actually there are not so many cases, I think. Or, well, let's try it. 3 makes this a 6. What if we make this a 1? 2 makes this a 6, sorry. That's 2, that's 8. We need another 13. And those are 3 and 2, and 13 has loads of solutions here. So 2 and 1 is very much possible. And lots of options in those cells. So let's try with 2 and 3. So these are 1 and 4. This is 9. No, this is 6, sorry. Making this 12, we need another 9 without using 2, 3, 1, and 4. That's not possible. What about 2 and 4? That's 17. No, that's 14, sorry. Then this will have to be 3 and 2. 17, we need another 7 without using 2, 3, or 4. And there's actually 1 and 6. So 2, 4 with 1, 6 in any order. That would work. Oh ho! Don't tell me that 5 would work. 2 and 5. That's 16. We would need another 5. So 1 and 4 would work. With 3 and 2 in here. Wow. So many options. Well, I'm beginning to think that I was not supposed to study all those possibilities so early in the solve. And what with the 6 here? That's 12. I would need 1 and 2. This one is not possible. And I'm a little afraid of trying with the 1 here. It would make this a 3. And how many options? So I'm starting to think that I'm doing too much work around here. I shouldn't be doing so much. There has to be something that narrows down all possibilities here. So let's just say that 1 and all this. So this is just 1, 2, or 3. And that will do the trick for the time being. But where should I look into? So this is about this. This 28 clue might have some restriction. Because that's actually a 14 cage with a triple digit. So this can't be more than 3 actually. 4 will make this a 12, and we would need a sum of 2 with the remaining 2 digits. That wouldn't work. 3 would go with 1 and 4, making this a 2. If this is a 2, then the cage has to include a 1. So, oh yes, there has to be a 1 in this cage, so this can't be a 1. And if this is a 2, then this is a 3, and this can only be 2, 5, 1. So this option is removed. And if this is a 2, well, if this is a 1, then what? This is a 1, then there has to be a 2 or a 3 here, which will pair up with this one. So nothing too certain about this. Making this a 2, that's 1, 4, 4, 3 in some order. No, 4 and 3. This one is the double digit. But what about this? So if that is a 3, then that's 9, and we need another 5. So that's 1 and 4. So 3 here implies a 2 here. And, well, and 2 here implies a 3, obviously. So 3 implies a 2, 2 implies a 3, but 1 could come with a 3. No, 3 couldn't come with a 1, because 3 is here is equivalent to 2 here, so I guess 1 here also comes with 2. 1 couldn't come with 3, so 1 here implies a 2 here, meaning that those are not possible. Well, I just track them down, just in case I've been mistaken. I don't think I was. What if this is a 2? So actually, the left-hand scenario is like this, and the right-hand scenario is like this. So either 1, 2, 3, 4, or 2, 3, 1, 5. This is so weird. And with this 3, we would have 1 and 4 in those cells. And I should align them differently. What with this? What happens? Oh, and if this is a 2, then that makes a 6. For a sum of 14, we need another 8 without using 1 and 2, so they have to be 3 and 5. 2 scenarios again. How can this have a unique solution? That's fascinating. This is a 13 cage, a triple 13, with some double digit. So this is at most 5. But 5 would come with 1 and 2, which is impossible because of this. So this is at most 4. 4 makes this an 8, resulting in a sum of 5, but both 1 and 2 are unavailable in either case. So this is not 4. This is 1, 2, or 3. What about 3? If I make this a 3, that's actually a 6, and those must add up to 7 without using 1 and 2, nor 3, so that's not possible. So this is 1 or 2. What about the 2? That's actually a 4, and we need another 9. So 2, another 9, without using 1, 2, 3. Without using 1, 2, 3, that has to be 4 plus 5, but 4 plus 5 is impossible because of this. So this 2 is removed, and this has to be a 1. So the right-hand scenario may be ruled out. Wow. That was a very, very subtle construction. And now what about this one? That's actually 2. And we need another 11, and that's 6, and that's 5 and 6. This one works, and those digits now are 7, 8, and 9. So that's the place I was supposed to look at. This region, the interaction between those 3 cages. Very nice. And now this one rules out this left-hand possibility. So there's no 4. Actually, there's a 4 in there. So this includes no 4. The real sum is 20. So that's not 9, 7, 4. But there are still other possibilities. So what are the possibilities for this 20 cage? 9, 8, 3. Not 9, 7, 4. So 9, 6, and 5. 8, 7, and 5. But no, this one is not available actually, because there's either a 5 or a 7 in this cage. So let's forget about this one. There has to be a 9 somewhere in this cage. That's 9, 8, 3 or 9, 6, 5. Well, this one says that this is not a 1. Oh, so this, I was right in not looking for all solutions for this cage with a 1 in this cell. And, well, the time I spent on putting a 4 here was not that useful in the end. But 2 and 3, so there are those possibilities. And there's a 1 here. All those options include a 1 here, so this is 2 and 3. And 2, and now none of them use another 2 or 3 here. And this one had a sum of 13, I think, yes. Plenty of possibilities. This has a sum of 12 times 3, that's 36. Where should I look? That's an 8-9 pair, implying a different digit here, according to the way they're dispatched. This 4 is somewhere in one of those cells. 2, 2. Oh, those ones. There's, by Sudoku, there's a 1 here. Oh, and that's nice. This one rules out 1 from this cell, so those are not possible. That's a 2. That's a 3 up there, together with a 2 on its side. So now there's a 1 here. And those are ruled out, so we now have either 4 here and 6 here, or 5 there and 4 here. Well, that's something again. There's a 1 here, but We don't know anything about this. This 23 cage is something completely mysterious again. What can we put in those? Those are double digits. But I see no restriction, no obvious restriction on this. So 2 and 3 2 and 3 are here, so they are removed from those cells, and we have a 2-3 pair here. So the remaining digits in the column are 4, 7, 8, and 9. But we know basically nothing about this. That's a 12 sum, and I guess it's bound to disambiguate this for these digits 4 and 5. Well, perhaps they are. Only this 23 cage and this 40 cage are available for some logic, for some arithmetics. That's actually a 20 cage with one double digit. 20 with one double digit. It couldn't be a 9, obviously. It couldn't be a 1, because those would have to add up to 18, and there's already a 1 here. That's not a 2, but anything between 3 and 8 would fit. No, actually 8 wouldn't work. That would make 16, and those would add up to 4, but 1 and 3 have already been taken, so that's not an 8. And 7 wouldn't work either. That would be 14. Those should add up to 6 without using 1 or 2. That's not possible. So this is actually between 3 and 6. And those remove all sums up to 7, up to 8. So those digits should have an even sum, but without using 1, 2, or 3, you can't have any sum up to 8. 10 is possible with 4 and 6. No, 4 and 6 is not possible either because of this. So this is at least 12. With 5 and 7. Or 4 and 8. So this is at least 12. So this is at most 2 times 4. So this is actually 3 or 4. And so 4 would fit with not 4 and 8, but 5 and 7. Not 3 and 9. And 3 would need 14. And both options, no, 5 and 9 and 6, 8 would work. So 3 and 4 are both options in here. Well, this is some kind of progress, I guess. Don't tell me that's this. Let's have a look anyway, because what is the minimum value using those restrictions? The minimum value would be with a, well, let's use another color, with a 2 here, 4 here, because this is not available. Then this would be a 3, and this would be a 5. And that's 19. Double 2, double 3. So 10, that would be 19. So there's not so much room. Oh no, 4 is not available here because there is a 4 in one of those cells. So that's not a 4, that's not a 4. So the minimum will be with 5 and 6, making this 21. So we have at most 2 more on the whole sum, which would make one of these 1 bigger. But that's not possible. 1 bigger for one of these would be a repeated 3 or 2 and 4, and 4 is not available here. And 4 and 2 wouldn't work either, so it's not possible to increase one of those. I can only do 2 more on the total of those, on the total sum of those. So let's say 6 and 7, or 5 and 8. But I think those 2 and 3 are actually forced. And any attempt to increase one of them would result in what? So is this 2 and 3? Let's really try. How could I do that? If this is 3, then this is at least 5. That's 16. That's 16. Those would add up to 7 without using those. They would have to be 1 and 6. And 1 is not available. So 3 and 5 wouldn't work. And 5 and 3 wouldn't work either for the same reason. Could it be 6 and 3? That would make 18. We'd need another 5, but 1 is not available and 3 is not available in the cage. And anything bigger would require 1, so that wouldn't work. I think this is proof that those digits are 2 and 3, and only this order works. I'm not that confident that this is the case. This feels like a proof, but oh, I hope this is correct. I really think this is correct, but that's so strange. Hey, great news, 3 and 3, so this can't be 3 and 9. It has to include a 4 or a 5. And that is really great news, because if this includes a 4, then this is a 3, and if this includes a 5, then this is a 4, and this has to be a 3 anyway. And this is a 5, and that's a 3. And now 5, 5, this has to be a 5, so this is an 8, that's a 9. This is not an 8. Those digits add up to 14. They must be 5 and 9 or 6 and 8. So which one is this? 4 and 8 or 5 and 7? I don't know. I really can't tell. This is not a 9. There has to be a 9 in one of those cells. Let's look some more into this. We already have 10. We need another 13. That's not a 9. That's not a 4, which is consistent. Oh, but there is a 4 here, so this is not a 4 either. This is not a 9. This is not 4, 9. It can still be 5, 8 or 6, 7. And I can't find a way to disambiguate. What will it be? This 9 says that there is a 9 somewhere in one of those cells. Now there's no 9 here, there's no 9 here, so there has to be a 9 in one of those cells. And there has to be a 9 in one of those, but we know that this 60 cage, this 20 cage actually contains a 9, so there's a 9 here. And we know there's no 9 here, so this is actually 6 and 8. 40 minutes already. So that's a 4, that's a 5. And now this cage is with 4 and 8 in this order because of this 4. Now that is not an 8, and this is an 8. In this column we still need 9, 5 and 7. That's not a 9. In this column, still need 1, 6 and 7. This is not a 6. That's not a 1. We still don't know about this. 9, 8, 3 or 9, 6, 5. These digits add a constraint to this. This can still be 8 and 5, but with 8 here and 5 there. 8 is in one of those cells. About this 5 and 8 or 6 and 7 is some order. Not much more to process. How can there be enough information to complete the solve? Oh, there's a 9 here, there's a 9 here, so this is a 9. Only place in this box. So that's a 7, that's a 9. Now those are 2 and 6. Four or 7. 4, 7, 8. 4 or 7 up there. 9 here or there. 4, 6, 7 and 9. Not a 4, not a 9. Well, on this row we still need 5, 6 and 7. Those are the options for this cell. Resulting in 8, 7 or 6. 3, 3, that's a 3. What about this? 983 or 965? With 165 we get 71482. That seems all right. 47. I don't see anything more coming from the cages. One here, there has to be one here or there. This 7. So this is not a 7. A 4 somewhere in one of those cells, because there's no 4 here. Just checking on the rows to see that I don't forget anything. No, there's nothing more. Nine, 5, and 7. Because of this 7, this is 509, 579. Those can't be 4 because there's already a 4 somewhere in this. So on this row, 4 has to be here or there. Oh, I'd been missing this. 3 and 3. There's a 3 in this cage, so that's 9, 8, and 3. 3, 8. 8, 9, 3, 8, 9, making this not an 8, and now we have a 4, 7 pair, making this an 8. Those are not 7s, so that's a 9, that's a 7. This is a 6, that's a 7, that's a 5. Doing some cleaning up. That's some progress. Now on this row, 6 can't go here because of this 6, 8 pair, so 6 is here. That's a 2. That's a 2 as well. 4, 7 in those cells. So now we have a 4, 7 pair. On this row, 2 is not here, it has to go there. Together with 6 or 8, but that can only be a 6 because there's already an 8 in the box. So that's 8 and that is 6. This 6 yields this 7 and this 6. And N. We're closing in. There's a 1 here. This 6 fixes this 5, 6 pair. 2, 9, and 5 because of these 2. Oh, that's a 5, that's a 9, that's a 2. 1, 4, and 8. This is 1 or 8. There's a 1 somewhere in one of those cells. No 5 here, but it could still be here. No 7 here, it could still be here. on this row. That's not a 7. That could be 7, 8, 9. This is, oh. On this row, we still need 3, 4, 6, and 8. 3, 6. That's 4 and 8. Or 8. This is 6 or 8. 3 can only go here. That's 4 or 6. So 7 or 9 here. 8 or 9 here. 7 or 8 here. Let's remember that this has to include a 4, so this can't be a 4. It has to be an 8. That's a 6. Pushing the 8 downwards. That's a 7. 9 here. 9 here. That's a 1. This will hold until the end, I think. This 3 and this 8. That's a 9, that's an 8, that's a 3. That's a 4, that's an 8. I may solve this under the hour. 1, 5, and 4. That 4 says that this is a 5. 1 and 4. That's a 1. This is a 5, and finally, that's a 4, 7, a 4 here and a 7 here. A 7 there. 4, 7. That's a 4. And this is a 6, and this completes the solve. Wow. Wow, that was some really some strange puzzle. Actually, the triple cages here were more, I'd say, Scrabble stuff. Those really had nice interactions. So that was both some kind of reference, of tribute to that beautiful board game that is Scrabble. And so, some parts were really, really fun. I mean, the very special arithmetics on this cage, on those cages, that was really, really nice. I really liked that part. Well, that's already a very long video, so thank you everyone for this so original creations, and thanks for watching these videos, and see you soon on SudoKanard.